Hey, want to make a couple announcements before I start today's lecture, continuing from Wednesday. So number one, at this stage, I would say probably the two most important things for everybody to catch up with is number one, get a Unix environment. Either it's a Mac or is on a window that you install something called WSL. And follow the instruction, make sure your G++ compiler as well as the make command are being installed correctly. Okay, so that's basically the number one things you should make sure you can get that done as soon as possible. And the second thing is that what you need to learn is go to the GitHub link I provide. The typical things you need to do is you go under the tab called Code. And under Code, you can download the whole thing as a zip file to your local machine. And then inside your Unix environment, you will unzip that zip file and just type make to see if everything will work. Suppose you install the Unix environment correctly, then the only thing you really need to do is just type make. And then your program should automatically generate to be either my break or person thing. You can actually do. Okay. I also record a video for today's, during today's office hour. I actually went through pretty deep with some help from some of you. Get to the basic and the introduction and some example about homework assignment number one. So I don't want to spend the time here to talk about homework assignment number one. I haven't actually posted that video because Zoom is still generating that video right now. But you should actually take a look. I think that will be helpful for you to tackle your homework assignment number one. Okay. Question? Yeah. Second, what's that? I'm not familiar with that environment actually, so I'm not sure whether it's. But the good thing for you to test it is whether you can run G++ and make at this moment. You can run G++, you can run make, you're probably okay, at least for a while. Because some of the environment will get, yeah, yes. Yes, there is a restriction. So in the make file, I actually already mandate to use G++ 14. So there is a different, thank you for the question. By the way, there were so many different versions of G++, but let me actually come here. If you take a look at the make file, you see that, not this one is C, so it doesn't matter. You go to CPP, no. If you take a look at the make file I provided in the GitHub for CPP001, you can see that I already declared CC, which is the C compiler. But the way I do it is G++ minus std C++ 14. So there are multiple versions. I feel for this course, you should use C++ 11, 14, or 17. Those three versions of the G++ compiler, because the compiler, they just keep changing the language. So you should use 11, 14, and 17. The reason I put 14 is based on my experience. 14 seems to be the most stable. Some of the feature a change for 17. Sometimes it works, sometimes it doesn't work. So 14 is the one. Okay. Any other question? Okay. Since I'm here, I just want to show you what I was talking about. Let me clean. So under this directory, this is the code I just unpacked from the zip file, which contain a bunch of programs we'll look at. At the end of the last class, we're looking at one thing I want to do is, by the way, I want to change this to dark background. How do I change this to dark background? Anybody want to help me? Shell, new tab or new, I will do a new tab based on Homebrew, maybe. Okay. This way, there is a suggestion saying that the recording might be easier for you guys to look at. Okay, is this better or worse? Better. Okay, good. Is that the font size is okay for the last row? Can you see it? Good. Okay, thank you. Okay, if you unpack, this is the just make it one more bigger. Yeah. This is the file you have after you unpack. So when I say you need to make sure your make file, your G++ is ready. So you just need to type make. There's immediately something is wrong. I'm wondering, what did I do wrong? GPS.cpp. Did I change it? Doesn't make sense to me. What was the error message? Unknown type name A. Wait a minute. This is embarrassing. GPS.cpp. Why this happened to me? Hold on, let me re-download everything. I think there might be something. I actually upgrade my Xcode between whatever opportunity. Let me actually go to the other one. Let me go to the example I had before during office hour, see if it still work. It was under document, ecs36b, CD, f2023, CD GitHub, CD CPP. So over here, there's no problem. Over there, okay, let me actually just re-download. I don't know what happened, especially I'm teaching a course now, so I have to just download everything from the beginning. Announcement, and this one, first lecture. Come over here, go to the code, and say download the zip. Okay, good. Unzip CPP01. Okay, already done that. CPP01. Okay, it's a warning. I'm not going to worry about that, but it's actually pretty strange because I thought I already changed it. Okay, but anyway. Okay, I'm going to continue using this one. Let me change the, wait a minute, which window was that base? Okay, so I'm going to, let me see, CP. Let me do this. CPP / GPS star here. Okay, I probably corrupt the GPS, so I don't know what I did. Okay, so now there's no warning. Okay, I'm pretty sure that now it's good. Sorry for the glitch. Okay, let me roll back to what I initially want to tell you is that you download the code. If you type in make, you should get exactly like this. It shouldn't give you any warning. If it's a warning, is maybe I put the wrong version there for the case I show you, but you shouldn't. I will try to check, double check. And then you should be able to generate the executable test thing person. Okay, so there was a few things. Just want to remind you that number one, this actually shows your make file, the make program is installed correctly. The second thing is that the G++ compiler has been installed correctly. Okay, so that's why I said at the beginning of the class, you need to have this Unix environment. You can run make, you can run G++, then essentially you should be able to run most of the stuff already in this quarter. Okay. And then after you generate this executable, you can see that previously you only have a few CPP file, but now you can see you have a lot of other files generated. You can look at the timestamp. This is when it's generated. The .o file stands for object file. You generate a bunch of .o file, and then most importantly, you generate an executable file called test thing person. So now you can just run testing person. It should run. It should actually generate an output like this. Okay, right. So this actually gives you a workable environment that you can actually, for every single lecture or every single example, just go to GitHub and do the same thing. And then if you can run, then you can start to learn and start to modify. And when you modify means that you change one line of code and to see what it is, and then you can actually just run make, which they will regenerate executable, and then you can do that. So if you're not familiar with a make file, look at the tutorial link I sent out through announcement. By the way, under the computer science curriculum, we typically assume you already know the basic command for Unix, and you're already familiar with what makefile is and how to use the compiler. And we have a different path to come to this classroom. Therefore, realistically, I know some of you are unfamiliar with some of the concept. So try to catch up with those tutorials, okay? All right, so now I'm actually going to continue from Wednesday. So on Wednesday, we actually look at this code. Okay, now I actually show you the source code. I actually show you how to run it, compiler, and then what should be the expected output. So now we're going to use this example for you to learn what C++ is, particularly how to define the class. Okay, so we are actually looking at this part last time. Only 3 lines. I believe this 3 lines already give us a lot of help to going into that. So let's look at just the first line. The first line, as I said, let me actually just comment it here so you know what we're talking about. The syntax The first part is the class name, which is the GPSDD. That's the class name. And then the second part is what we call a variable name. In this case, because it's actually after the class name, it's actually the object of GPSDD. And the third one, I will just tell you first, and then we'll see why is that. This is called initialization. Initialization or construction of the object. Okay, so we're actually looking at three parts. The first part, let me actually just tell you, the first part is the class name. The second part is called GPS home woodland. And then the third part is essentially between the curly bracket. And of course, for every C or C++ program, you have this ending semicolon. Okay, so that's actually, I'm going to upload this annotation about what we just went through. So essentially, it's a class name, it's an object variable, and there's some initialization value. So now I want to tell you that what is a class? So it's a class you can think about is like a specification or a template of a particular type of objects. So for example, when you actually declare in C programmer, you must have written some code looks like this, right? Have you actually written code like this? Int I is equal to 5. It's basically I define an integer. So what is the class name here? The class name here is int. That's the basically specification, means that whatever object after the type is an object according to the property about an integer. So int I is equal to 5. What is a 5? 5 is an initialization about the value. The syntax might be a little bit different, but int I is equal to 5 is essentially structurally the same as saying that GPSDD, GPS home woodland, and then a bunch of other things I want to initialize. I mean, the reason it looks complicated is because int or I is something we call the basic type. So its initialization is very simple, just one value. But object is much more complicated. And therefore, I need a more complicated way of specifying the detail about the whole object. Okay, so this is the first piece of code about this woodland, whatever, the GPS home woodland. Any questions? Okay, now I want to give you a short break for you to do something differently. Can someone tell me what exactly is this location? I'm guessing 50% of you have already visited this place. Maybe 30%, because some of you are freshmen. Anybody want to guess what that address is? Yes. Costco. How do you know that? Did I tell you last time? Okay. It is Costco. Okay. So how do you actually enter that? You just pick up this 2 number, okay? The way to do it, you pick up this 2 number. And let me open my browser. Let's go to map. You go to Google Map and you search, you just search, you enter this pair of number and you actually search. That's looks like it's a Costco in Woodland, okay? So of course it's not my home, but I feel that's my home because I went there a lot. Okay. So this is actually what we call GPS location. So GPS location is giving longitude and the latitude. So with this two floating point, you basically can represent every single location on Earth. Okay, that's why it's this two location. Okay, great, thank you. Did you go to Costco a lot? You can even remember the GPS location. That's a good sign. Okay, yeah. Well, I'm impressed. Okay, good. All right. So this is the way I specify. I initialize a GPS object, and then basically allow me to enter this two initialization values. So meaning that what is a GPS location? GPS location can represent Washington, D.C., can represent Tokyo, can represent Eiffel Tower, can represent everything. That is what? That is just a class called GPS location. But the content of that location is going to be determined by different objects. So I define a variable is essentially I create an object called GPS DD, but then it just follows the format about GPS. But unless you actually enter those two unbelievably difficult to remember number, you won't actually know the realization of that object. Okay, so that is a relationship between class and object. So I just want you to take away from this. I'd probably ask this type of question next Friday, is what's the relationship between a class and object? Class provide the design about the object you're trying to realize. So by using the syntax saying that object, class name, and then object name. And then, by the way, the third part is actually, I will call it optional, because sometimes you don't have to initialize. You can just create an empty object and then gradually doing something for it. Okay, so that's the class and object. Okay, any question? Now let's go into the class itself to see how to actually define a class. So let's go to GPS.h. So this is the definition. So for most of the convention in C++, we want to define each of the class with a .cpp file and .h file. And usually we started with the .h file. So you can probably, don't worry about the first few lines until here is what I want to do, okay? I'm actually going to explain just this part. Okay, again, I want you to guess. For this probably 12 lines of code, I just highlighted here. Why don't you take a look at 30 seconds to see what the code is trying to do? What are, I'm not saying what are the codes trying to do, it's just what did you see? What information is actually being included? Which information do you think it should be included if it's there? What information do you think it should have been there, but it's not? Okay, so that's my next challenge to you. Can you see it? By the way, I feel sometimes is yes in the back. Sure, go ahead. Say the last part again. Okay. Okay, let me actually parse your question. So the first is related to the public, right? We have three keywords, public and what other keyword? Hold on. Private and public, right? Okay, and you said it's related to the execution. But we will see that. Okay. What other things you see there? The public, private is a good things we need to learn. Very important. But what other things you see? Yeah. I define variable. Okay, what kind of variable I define? Okay, I have two variable, latitude and longitude. Do I have other variable besides, let me just ask, do I have any other variable? Just these two. Okay, good. So there are some keywords which explicit, which is, just remember that as good observation. We will tell you what it is. I think we will say, yeah.
The two methods also get latitude and get longitude.
Okay, there are something we call method. The word you use is method, right? Okay, or function. And how many of them? Function. Which are the name of the function? Get latitude. And get longitude. Hold on. Let me just. Make a mistake. Okay. In the front, yeah. Change color to the background or the foreground? You cannot change the purple. This is the Emacs. They changed the color. So you know what? I'm going to do this. Sorry about that. Okay, it's not my color. Is this looks better? Okay. Yeah, that's what I'm worried about when I have a background, depending on the color. Okay. Any other question? Yeah, in the back. Okay. Before I get to that, good question. I think one of you say there are two functions, get latitude and get longitude. Do we only have two functions? How many functions totally do we have here? 4. In fact, we have 6, including the one that you just pointed out. We have 6 functions. Okay, all of them are functions. We have 6 functions here. And before I actually tell you why we have the function looks like the same as a class name, which is GPSED, I want to tell you that now you understand what a class looks like. What is a class? It's basically class. Okay, sorry, I'm going to do the annotation again. It's just class as a keyword, and then the name of the class. And then you have a pair of curly bracket. Inside curly bracket, you have something called public, or you have something called private. And then the rest, you have either variable plus a bunch of function. Right? I mean, does that summarize what we just learned from the whole code? When you define a class, you gave me a name, and you gave me a bunch of variables, and you gave me a bunch of functions. That's it. Okay, so I'm going to ask you some of the question about C. Okay, I assume some of you at least still remember. In C, when you define a data structure for struct, right? For C programmer, please help me. I forgot everything about C, so you have to help me today. So we have a struct. And what is the syntax of a struct? So the keyword is a struct. After struct is what? The structure name, right? Struct. Let me see if I can find something over here. It's actually struct. And then you have a name. I mean, you can have name before, after the curly bracket, that's fine. And then you have a pair of curly bracket. And inside the curly bracket, what do you have? Anybody remember C programming when you do struct? It's a variable name. By the way, just secretly tell me who your ecs36b professor was. I will actually use this one to hit his hand 20 times, okay? Just kidding, just kidding. Okay, so in C, when you have a struct in the name, and then inside that curly bracket is a bunch of variables. Everything there is a variable. Can you actually put a function inside that struct? You can actually put function pointer. I believe most of you probably, some of you might learn the concept of function pointer. So it's a pointer, but instead of pointing to data in the memory, it's pointing to a function. And you can actually have a variable which is pointer to a function. In fact, that is how C++ implement the concept to kind of, so you actually see that C++ is an extension about what C language is. Okay. But anyway, I want to tell you this. We have, this is a class define. What I want you to learn is that if I say, hey, today, so-and-so, please write a class for me. Then you basically think about follow this line I just highlighted. You say, put a class, give the name of the class. And then in between that curly bracket, you try to think about, well, what kind of variable I want to put it there, and what kind of function I want to put it in. And well, then you will say, well, how do I know what should be the variable, what should be the function? Depending on what you want to model. Remember, it's a language. A language is trying to represent the real world, represent person and thing, and whatever you want to do in the real world challenge. And therefore, in this case, I define a concept called GPS. And under GPS, I need two variables, longitude, latitude, those are enough. And you want to define a health of your instructor as a person, what kind of variable I should put in. I should put in the blood pressure, the whatever, all this measurement, and to represent how healthy I am at this moment, right? So the thing is really application dependent, and then you define that. Okay, so now I want to focus on the function. So I have a 6 function defined here. Yeah, you have a question back there? Yes. No, doesn't matter. You can do any order you want. I will let me very quickly tell you why it's a public and private. It's so important concept. For some of you, this could be very challenge to learn about this. Is what is a public and private? Meaning that if something is in the public, then basically anybody outside of this object will be able to access. If it's a private, only within the object that you can access. Okay, in English, I think you can understand me syntactically, but semantically, what I just said maybe make no sense to all of you, because what do you mean by outside? What do you mean by inside? Let me actually take a look at the picture and then come back. So what is an object? An object looks like this. Okay, now I'm actually using a illustration about an object. So whenever I think about an object, I actually think about a picture that looks like this. So you see that an object has a boundary. So for example, me as a person, I'm an object. What you actually see is my outside or my interface. But internally, I have my, say, any important psychological state, or my some kind of not so obvious feature, such as the rate of my heartbeat. Okay, and those things are the data variable inside the object. So immediately when we talk about an object, we have a concept called outside and inside. Anything that's actually outside of this object is outside. Anything inside. So let me actually take a look. What do I mean represent the code? Remember, we have this program called test thing. And remember, I have, what is this? I just want to test you. What's GPSDD? It's a class name, right? It's a class. The name is GPSDD. What is GPS home woodland? It's a variable, but it's an object, right? It's an object of what type is GPSDD. So the object is there. So, okay, so now I want to say, from this program's perspective, that I am an outsider of this object, GPS homeland. Let me actually tell you to introduce a mistake. So can I do this? I'm going to use C syntax, printf. The latitude of the latitude is %f. Let me just put %f. And then I will say GPS home woodland. And then I would just say dot latitude. Okay, so you can see that I actually create an object called GPS home woodland. And it has two variables. Let's actually side by side look at this. So over here, I have my object GPS location. You can see that I actually have something called latitude. Now I see I add one more T. And one more T. Okay, I have this. This is my definition of a class on the top. This is the code. I create an object. I actually try to access one of the variables in the object. By the way, how do you actually access the variable of a particular object? Object name, dot, and then that variable name. Will this code work? This code will not work because why? I'm actually trying to access something private from the outside. Remember I said if it's a private, then I can only access inside. But this one, let me try to run it. Try to compile it. You see that is error. Look at the error message. It says latitude is a private member of the GPSDD. Okay, so that's the difference between private and, so let me actually change the code. So that's why I want you to sometimes twist the code a little bit. I mean, how do I make the code to work? It's very easy. I just make this latitude, this line, I move it over here. Now you see what I did. I actually changed the latitude such that the latitude now is under what? Under public. So if I save it, and then if I do make, everything works fine. Okay, so that's the difference between latitude and the latitude. The private and the public. I better change it back, otherwise I forgot what I did. Okay, any questions so far? Yes, on the back. I create a stack, S-E-A-C-K. That's actually, you're asking the question 7 weeks in advance of my curriculum. Just 7 weeks, okay, not 10 weeks. So that's a good sign, okay? We will talk about something called STL, Standard Template Library, which is including a lot of common data structure in this step, okay? Just, yeah. Can you speak a little bit? Excellent question. Why do I even bother to differentiate public and private? Why not just put everything in public? Yes. Okay. Well, unfortunately, even if you have the same name, regardless how you put private, public, it will cause conflict. But there is an issue related to the same name, which I will explain, is that if inside even the function implementation, which we will talk about that on Monday, that in the implementation of this function, for example, get latitude, get longitude, you use a variable name, that sometimes is confusing. We'll see that. But okay, I will close this comment as say you have a good weekend. Why we want to have a private and public is really for protection. It's really for protection. So over here, GPS.h, who wrote the code? GPS.h. I wrote the code, right? And you guys are going to use GPS.h, GPS.cpp to do something, right? So I designed the class. And I said, I want to put it in the private because I want to forbid you to actually make certain direct access. Because I actually know to protect the data, because the worst thing is that I actually put everything in public and sometimes you just randomly change it. With C programmer, this is even worse because you can actually use whatever pointer or address, you can change a lot of things. So this at least give me some differentiation, means that if you want to access a variable, you better use one of these public functions. So that's why you have this function called get latitude and get longitude, because I force you, or the compiler force you, enforce that you want to access this, don't modify, use this function. Let me actually just show you how that looks like. It's actually very, very simple. You see that? This is the code. Implementation of get latitude. It's almost, you will think that this is redundant, but it is not. It's just trying to enforce you to read the variable without the capability of write to the variable directly. So you can see that this is a function called get latitude and just return this to the latitude. What is this part? This is the function inside object, so this is insider. So this is the insider, we can access to find the variable. Okay, I'm going to stop here. We're going to continue this on Monday.